and hope you learn new things. And thank you for joining us on this one. So we call this webinar Assistive Listening Technologies in the 21st Century because this is where we are now. Um, we still have a long way to go in the 21st century. Sorry, one second. So I'll start by talking about why assistive listening is needed. Why do we need to integrate assistive listening? I'm sorry, I haven't shared my screen. So why do we need to integrate assistive listening systems in society? Hopefully you can see my screen now. Um, People with hearing loss generally have trouble to understand speech in environments where people with standard or normal hearing have no problem. Um, I will mention a number of times in this presentation the term signal to noise ratio, or SNR. SNR is really important. This is the aim of assistive technology, to improve the SNR. That means to increase the decibels by a level of 15 to 20 decibels for people with hearing loss, in order to enable them to hear it and understand at the same level as people with normal hearing. An assistive listening technology allows them to gain that gain, um, and also to adjust the volume for their liking without disturbing everyone else. There are three parameters that are very important to improve comprehension, and this is to cut out the background noise or filter it out, to override poor acoustics, and reduce the distance from the sound source. Um, Before we go in, let's have a look at why the extent of the issue, the statistics of hearing loss worldwide, and it's very similar in every country that we go to. So predominantly 1 in 5 people around the world would have hearing loss. So it's 1.5 billion worldwide, and it's 125 million people in Europe. Um, Hearing aid usage is growing, as is hearing loss. In fact, the World Health Organization estimates that hearing loss in adults will be at the top 10 diseases by 2030. So you got all the statistics here. It's basically a disability or a condition that affects a lot of people worldwide, and very often is not realized. In America, in the US, 73 million people have significant hearing loss. Again, it's 1 in 5. Obviously, in older ages, the percentage and the number of people is higher, so it's 1 in 3 out of people over the age of 65. In the UK, over 13 million people with hearing loss. 6.4 million out of those with hearing loss are at retirement age. And again, by 2031, the estimation in the UK is 15.5 million people of the population, so 20% of people in the UK. So it's a significant chunk of the population worldwide, which would explain why assistive listening is needed. The main causes of hearing loss are varied. There's about 10 different causes of hearing loss in adults. The reasons that you see on this slide are all medical reasons. So it could be because of medication, it could be disorders that cause sudden hearing loss or gradual hearing loss. It could be issues with the inner ear. So these are all medical reasons, diseases and illnesses that can cause hearing loss in adults. This slide shows other reasons. So exposure to loud noise. People have been in military or workplaces that are exposed to high level of loud level of noise. Acoustic reasons, but predominantly one of the main reasons is what is the last point in this slide, which is hearing loss that occurs as we get older. So speech starts to sound more muffled, and very often this is due to the loss of high frequency sounds. So it's not as though someone switches down the volume, it's the lack of ability of the ear to receive high frequency sounds, which makes sounds very muffled, and also uh, reduce the ability to hear and comprehend the total frequency bandwidth of what we need to hear or what we were able to hear when we were younger. You may have seen this slide in other presentations we've done in the past. So perfect hearing looks like this on the left, and impaired hearing looks like the slide on the right. So we would hear part of the conversation, and we would try to make out what is being said and what we are actually trying to hear. So it's just like the loss of sight, where I'm not able to see the full picture or the full um, thing of what I'm looking at, and I'm only able to see parts of it, and I need assistance, i.e., spectacles or glasses. Um, when we are detected with or diagnosed with hearing loss, we usually go to the doctor. The doctor sends us to an audiologist or a hearing clinic, and we get an audiogram done, which identifies the pattern of our hearing and identifies the characteristics of the hearing loss that we have, whether it's high or low frequencies or other frequencies, and the hearing aids are then adjusted accordingly. In real life, the more decibels I'm losing, the less sounds I'm able to hear. So this diagram shows an example of a decibel loss of 60 decibel, and I'm stopping to hear my baby cry or my dog barking and so on. And it also shows the loudness of things, how loud things are. So um, a drummer playing a drum kit is 120 decibels, which is 1,000 frequency cycles per second. So these are important things for on your audiologist or a researcher to understand in order to identify my particular hearing loss compared to another person. Um, so society and technology and the world has created a solution for hearing loss. Many years ago, the solution was hearing aids or hearing instruments. It's not just hearing aids, it could be cochlear implant receivers, which is a different device, but ultimately it's doing the same thing, which is amplification of the sound. Um, Technology and manufacturers have created a number of types of hearing aids. I'll get into it in the next couple of slides. The hearing aids are either in the ear, in the canal, behind the ear, or body-worn hearing aids. Those devices are obtained from specialists, from audiologists, following the hearing test and the findings in the hearing test. So hearing aids were put out as a solution to help people hear better, people with hearing loss. The different types, the most popular types of hearing aids are 5 different types, starting from right to left is behind the ear hearing aids. This type has a bigger receiver, a bigger cabinet that holds all the components, the electrical components that the device requires. Because it's got a bigger cabinet, it's able to host in this cabinet a bigger amplifier, usually with high amplification and more capabilities because there is space in the cabinet. Telecoil is one of them. Bluetooth receivers could be, and other things that can be hosted inside that cabinet. The smaller they get, the less space there is in the unit, in the cabinet. So the less space you have in the cabinet, the manufacturers have to start compromising. That might be smaller batteries with less battery life. And it might be that they do out without certain components such as telecoil, such as Bluetooth receivers, etc. The smaller they are, the less space there is physically inside the device. The hearing instruments, the hearing aids are a great invention. They help people hear um, in many environments. However, they are not perfect. People think that, oh, I'm going to get a hearing aid, it's going to solve all my problem. The reality is that they have a very limited range, usually up to 4 or 5 meters, which is about 15, 16 feet. The reason is they have a very small microphone cramped inside an electronic unit. The microphone has limited capability. The bigger the microphone we can install, the more sounds, the bigger the range will be. Currently, 60 to 70% of hearing instruments issued worldwide globally have telecoils, which are needed for use with hearing loops. It's worth mentioning the telecoil is a function, is a feature in the hearing aid. If it's not activated, it's not working. If it's activated, it will work. The activation is done by the audiologist, which is something I will touch on later on. Um, and of course, it's like anything else. I can buy a top of the range, very modern television that has a lot of features. If I will activate these features, the features will be active. If I leave them switched off, they will be off. So any feature that I have in a hearing aid needs to be activated and working in order to benefit from what this feature can do. The modern world over the last probably 50, 60 years has created the standards and legislation. The creation of the standards legislation was to help uh, accessibility that is driven by legislation. It means that uh, technologies are enforced in the standards in order to be able to be integrated into public spaces and other venues. Um, Again, this is from the knowledge of people that need help, people with hearing loss that require help in the same way that somebody with a wheelchair or in a wheelchair requires help in certain scenarios. Um, Standards and legislations are a law, and in many countries, there are severe consequences for people that are not following the standards. On the flip side of it, there are countries that have no standards whatsoever, or they have something and are not enforcing it. We see many countries, including westernized countries, that have no standards, and the integration of hearing technology, assistive listening technology, is driven by advocates and other movements like charities that drive the provision of accessibility. So the world really varies. If you look at the entire world, there is a huge variation in terms of the standards and the integration standards. So just a quick scan of the standards and the legislation around the world, starting from top of the pyramid. So the United Nations published a UN Convention on the Rights of People with Disabilities many years ago. This convention is a very general very general document. It's a document that promotes the rights of people with disabilities worldwide. So it acknowledges the fact that every individual have equal value, the right to make their own decisions, regardless to disabilities, and that people have to be treated fairly in the society. It's a very general document. It's not a document that was enforcing anything specific, but it's prompted many countries to develop their own rules and regulations and acts for the rights of disabled people, including people with hearing loss inside it. So some examples, again, starting from the top, going down the pyramid. So the Europe or the EU. The EU the Europe is interesting because it's split to so many countries. So what you see in the EU or in Europe in the whole, you see individual national standards. So every country has its own standards for accessibility. Some countries have had it developed for many, many years. We have on this call some of our partners from Scandinavia, and Scandinavia is one of the pioneers in terms of a good example of integration of accessibility on the whole, particularly for people with hearing loss. Um, in 2021, the EU has launched the EN 17210. It's an accessibility and usability standard in the built environment. And this is the first time that the EU has launched as a body a very, very detailed document that not only enforces the integration of assistive listening, but also gives concrete examples of what should be integrated where, starting from meeting rooms, small meeting rooms, small one-to-one situations through to large auditoriums and convention centers, etc. Um, the report was prepared, this document was, or this standard was prepared under mandate from the EU. It was signed, interestingly, it was signed by European countries that are also outside the EU. So the 34 countries you see on this list, you will see that some of them are actually outside of the EU, but it's been accepted and signed by those countries as well. Because this standard is quite young, it's only been out for 3.5 years, it is still in the stages of implementation into the different countries in reality. So it's not only the integration of technology correctly, it's enforcing it. That's the challenge here. If we look at the US again many years ago has launched the ADA standard, the Disability Act standards, which states that assistive listening systems are needed in certain facilities, civic gatherings, and public venues. The ADA is very detailed in terms of specification of the technology needed per number of people. So if X amount of people are together in a public space, um, over this amount you have to integrate the society, whereas the European standard doesn't specify necessarily a number of people. It also doesn't specify number of receivers, like the ADA does. Um, the ADA, interestingly, the ADA does recommend or does recognize four technologies currently, which is hearing loops, FM, infrared, and direct wired equipment. It takes a long time. It's worth mentioning that it takes a very long time for any technology to be recognized, tested, and approved, not just by the US, but by any country. I can tell you that from the UK, adding a new technology to the standard, it's something that can take 10 years. And we have seen it with the BS standard, which I will touch on now. Um, so the UK, as an example, I'm not going to go through all the countries. The UK, because we are a British company, the UK had the Equality Act and Part M of the building regulations from the mid-90s. And this tells businesses that they have to make certain adjustments to help people with hearing loss, which was very broad definition. Part M of the building regulations gave more specific advice on which technology should be used and what the requirements are. So how it should be done and how it should be published to people that need to access technology. Then in 2018, 6 years ago, the UK has updated its building standard, which is the BS. BS stands for British Standards. So BS 8300 has been modified or has been updated. This update alone took something like 4 years. So by the time an update of a building standard is being launched, they already work on the next one. This is how long it takes to update a standard. And it's not just technology, it's many other aspects. The BS 8300 has complete sections about hearing loss, explains the needs of people in the public environment, and gives instructions of what technologies should be integrated. It is details. It has incredible details in terms of requirements for hearing loops and also other technologies. It gives specification, provisions, locations where you should put things, how it should be accessed by the user, best practice in terms of maintenance, and also training of staff that serve people in public venues. Very importantly, in the UK, it was the first time in 2018 when the BS 8300 revised BS 8300 was published. It was the first time that a standard can actually be used by consumers in the court of law. Before that, the BS 8301 was just a document. It was not relevant or had no leg to stand on in a court of law. But the BS 8300-2, the revised standard, is a legally accepted document. So this is what the world has created. It created hearing aids and then standards of how to implement technology in the built environment to help people access the sound and receive the sound in the right SNR. So what's available? Um, Looking at the people on this call, it's not going to be necessarily news to anyone, but nevertheless, I'll cover everything here. Um, like I said, the integration helps people in noisy environments and also helps people to hear at greater distance than what their hearing instruments can let them hear. So if a hearing aid let me hear in 5 meters, the technology that's implemented in space will let me hear at much greater distance. There are 5 technologies that are currently popular um, in terms of assistive listening: hearing loops, infrared, radio frequency, Wi-Fi, and Bluetooth, and we'll cover all of those. Starting with hearing loops, I'll go one by one, and we have pros and cons on each one and show some examples, including a video clip. So hearing loops are installed throughout the world. One thing we have to remember that a hearing aid has a microphone built into the actual hearing aid. This little microphone amplifies all of the sound around me. It doesn't distinguish between different sounds, or it doesn't know what sound I'm actually wanting to hear. It amplifies all of the sound around. Even though modern hearing aids have apps that let me control this microphone in greater detail and improve that, but this is quite recent. Most hearing aids that are available are amplifying the entire sounds around me. Um, Hearing loops are great in improving this by basically killing off, reducing this ambient surrounding noise, and let me hear just the sound source very, very clearly. So they cut out the background noise. So how does the hearing loop works? Again, looking at the people on this call, I'm not sure if it's gonna be any news to anyone, but nonetheless, there is an audio source, and it can be a microphone, a PA system, smoke alarm, anything that produces important sound that we want to hear. It's connected to the sound source is connected to a hearing loop amplifier, or driver as we call it. The hearing loop amplifier is actually a very clever device. It's a device that's able to receive an audio source, an analog audio source, and by clever electronics, it's converting that source into two things: current and voltage. And it's then driving this current and voltage into a copper tape or a copper cable. The copper cable is located or installed in a certain area. And as soon as I drive current and voltage into a copper cable, naturally it produces a magnetic field. I call it a cloud. It produces a cloud in the area of the copper wire. And that cloud, when it's adjusted correctly and controlled correctly from the amplifier, is able to deliver the sound through the magnetic field. That means, in an induction way, that means that everyone with a hearing aid equipped with a telecoil can step into that cloud, into that area, and the hearing aid is then converting the sound from the magnetic field back into sound that I can hear in my ear. So this is the concept or the principle of a hearing loop. What is a telecoil? I mentioned telecoil. So what is a telecoil? A telecoil is a small copper wire built into the hearing aid. It's literally anything between 3 and 6 millimeters long. So it's very, very small. And there's a wire that goes around a copper cylinder many, many times. So it acts as a receiver. And essentially, simple science, it's able to pick up the sound transmitted, sorry, from the magnetic field. So the magnetic field is an emission of sound, and the telecoil is a device that's able to pick that signal up. It's transmitting into the hearing aid amplifier, which is then able to convert it back into an analog signal. And it's the analog signal that is then sent into the ear through the ear hook. And if users are using a mold, um, they can hear it through a speaker that's installed deep in their ears. Um, the telecoil is passive, it's a passive device. It will convert only the sounds that are transmitted through the magnetic field, nothing else. It's not able to receive any other sounds through other sources. It will pick up only what it can get from the magnetic field. It's worth mentioning that the telecoil is in the hearing aid is positioned in a certain angle. It's not that I can put a telecoil anywhere or in any way inside the hearing aid. It's positioned in a specific angle so that when I wear it behind the ear, it is perpendicular to the signal that comes from the hearing loop. And we'll show it in the next couple of slides. So essentially, the concept of the hearing loop is a sound source. Number one can be a microphone or anything else. It's transmitting sound into the hearing loop driver, which is number two. The hearing loop driver is physically connected to a copper wire, and the copper wire surrounds an area, a designated area, either as a crisscross way, like you see here, or as a perimeter around a specific area. And the delivery of the sound is through the telecoil. So a telecoil that is positioned in the right angle within that area will pick up that sound. It will pick up that magnetic emission and convert it back into sound. Um, Perpendicular to the emission is very important because if you've had experiences in large area loops, you will notice that when you bend down to pick something you drop on the floor, you usually stop hearing the loop because you are now taking your telecoil out of a perpendicular position and into a flat position. Equally, if you install a hearing loop in the wall, you're not going to receive the sound because you're in the wrong orientation. In order to receive the sound, you'll have to lie down. So the angle of the telecoil inside the hearing aid is critical, and hearing aid manufacturers know this obviously, and they install it in a particular angle so that when it's installed in the ear or behind the ear, it's in the correct angle. The benefits of hearing loops. First and foremost, it is the only technology that has a universally accepted installation standard. Okay, it's the only technology that has an installation standard. That means that any hearing loop installer has to follow a particular standard. When they follow the standard correctly, they achieve predictable results every single time. The installation of hearing loops is discrete. It's either in the ceiling, under the floor, in walls, etc. So it's not something that is visual or require any visual adaptations. It's easy to access from a user's perspective. It's a technology that delivers direct to the hearing aid. The hearing aid user keeps their confidentiality. They have to press a button on the hearing aid to activate the telecoil and switch off the microphone. So there's no drawing of attention to myself. There's also no latency. So the sound that somebody is talking into the microphone is delivered to my ear immediately, like natural hearing. Hearing loops are excellent in producing intelligible sound. So the hearing loops are ideal for speech, possibly less for music. The other benefits is that hearing instruments receivers can access the sound in the same way, can access the hearing loop sound in the same way. So it doesn't matter in which hearing loop I'm using or which country I'm in, it works in the same way for me as a user. I know that I can access it by pressing that button every single time, no matter which country I'm in. It's ideal for walk up and walk through locations, can be used outdoors because again, the magnetic field is not impacted by sun or rain or anything like that. So it can be used outdoors or indoors. It's very versatile. It's probably the most versatile technology because it can be integrated into anything. We install hearing loops into anything through from ticket machines or ATM machines through to large auditoriums. So the same technology with the same access can be installed in many applications. We install hearing loops almost anywhere. An important point is it draws no power from the hearing aid batteries. Other technologies draw quite a lot of power from the hearing aid batteries, which means as a user, I have to think of spare batteries or how am I going to replace or recharge my batteries. A telecoil doesn't need power. It's not powered by the batteries. There's low maintenance for hearing loop systems. Once they're installed, the hearing loop amplifier stays on and they're always on. And the last point is we have now very advanced design softwares that help us to really accurately and in a very advanced ways to control the performance in large spaces. So we can control not only the coverage but also the overspill around the loop up to distances of centimeters or feet. So we can really control a signal and make it work better for the user by correct layout with very advanced softwares. The considerations or the cons of hearing loops is that the telecoil is a magnetic coil. It picks up the sound from the magnetic emitted magnetic signal, but also it is susceptible to EMI, to electromagnetic interference. Magnetic interference is something that is transmitted into the air through different things. It could be a faulty wire in the wall that we don't even hear with our ears. It could be a cellular phone, anything else that has current running through it and maybe causing interference with something else. So hearing loops are susceptible for EMI. And that has to be taken into consideration. Privacy of the sound, as I mentioned, requires appropriate loop design. So if you just throw in a wire on the floor and you're not going to do the design properly, the likelihood is that the performance will not be ideal. Metal is another issue. Metal content in building structure can cause signal loss because we're emitting. Hearing loop doesn't emit EMI. Hearing loop emits a magnetic field. Very often people contact me or James or someone else from the team in Contacta and say, uh, I'm installing a hearing loop. Is it going to have issues with it? Is it going to cause EMI with my other system? Hearing loops do not cause EMI because they're not emitting electromagnetic signal. They're emitting a magnetic field only. The flip side of it, that metal in the structure of a building or in a structure of anything um, can absorb some of that magnetic field. A lot of metal will absorb a lot of that magnetic field. So that has to be taken again into account when designing a loop. Um, And obviously, hearing loops will only transmit in one channel, single channel, so you can't get stereo transmissions from a hearing loop. So if you were looking for high quality music concerts, etc., the benefit from hearing loop is the clarity of sound, not the quality in terms of bandwidth and not stereo. So to wrap up hearing loops, I've got a very short video that I'm going to play. It's less than a minute long. It's about 40 seconds long. And it's Tim Mills, one of our senior engineers, demonstrating a hearing loop that we installed with and without the telecoil. So the first part of the video, the first 20 seconds or so, is Tim talking to a microphone, talking without a microphone, and you can hear the reverberation and the echo in the sound. It's very difficult to comprehend. and he then switches a microphone on and then starts talking into this microphone, and that microphone is connected to a hearing loop. And this demonstration is very good because it shows the impact of hearing loop and how it works for the user. So essentially, the first part is without the telecoil. The second part is with the user switching on the telecoil. So hopefully you'll be able to hear it. We've shared the sound, so this should play pretty good. You might want to switch your volume up a little bit.
The audio you're hearing now is equivalent to hearing aids set to the M position, and the distance between us is noticeable with the echo within the room. The microphone I'm using now is connected directly to the loop system, and when you switch your hearing aid to the T position, you are now tuned in to the hearing loop system, and as you can tell, the quality of sound is far, far better.
So even though Tim is only standing about 4 or 5 meters from the camera when we shot this, the actual sound is very echoey. You can hardly tell a difference. You can hardly understand what he's saying. And that's natural hearing without anything. This is how I would have heard it through my ears. As soon as he switches on the microphone, it's like he's standing right in my ear, and that's what I meant by cutting out the distance. Um, Hopefully you was able to hear this video. All the videos, by the way, are available on our YouTube channel. Maybe a good opportunity to mention our YouTube channel because this video as well of this presentation will be published on the channel, and we have over 50 great videos on our channel. We're recording some more, really worth having a look on YouTube. Search for Contacta and then find our account and then look at videos that we have published. So I'll move on to the next technology, which is infrared or IR. So infrared works on a completely different concept. The sound is transmitted from a source to from the sound source to a transmitter. The transmitter is a physical device. It's a physical device. Transmitter looks like an amplifier or a radiator that's hanging high on the wall. And that transmitter is basically flooding the room that we want to hear in an invisible infrared light. Infrared light is light that is used in many applications in our life. Sometimes we're not even aware of it. The remote control of televisions, for example, is usually infrared. So you point it towards your television to change the volume or change channels or settings. And the transmission from your remote control to the television is through an infrared light. We don't see that light, but there's a ray of light that's connecting the two. So it's the same principle in the same way. The transmitter takes the sound source and floods the area with invisible infrared light. And the receivers that want to access that sound will need a compatible personal receiver to be able to access and hear the sound from that transmitter. So at a glance, we have a transmitter on the wall on the left. Usually we install it at height, pointing downwards because it's a principle of line of sight. So we want to make sure that every receiver would have access to that line of sight, to that transmission. So the transmitter will flood the area with light, and then different types of receivers. The user will pick up a receiver and will physically wear that receiver on them or use that receiver on their head, in their ears, to be able to receive the sound. The transmission then from the receiver to the hearing aids is done through a neck loop. So they'll have to plug in a neck loop into the receiver to receive the sound through hearing aid with telecoils, or no telecoils, no hearing aids, and you're using a headset or earphones that are plugged into the receiver. So physically, each user that want to access the system needs one of those, needs one receiver, and that's also a disadvantage of an infrared system. Infrared system, at least our system, can transmit either in one channel or two channels, which enables the two channels enables either stereo listening or to jump from one channel to the other. For example, translation in two languages. I can have one language on channel one, the other language on channel two, so the user can choose. So the way it works, the transmitter would flood the room with this invisible light, usually in an egg um, shape as demonstrated here. It's not Sometimes it's not ideal and it doesn't cover the corners of the room, depending on the size of the room. But it's usually like an egg-shaped coverage. You can pair up two transmitters, as shown here, to increase the range or to increase the coverage. But by doing that, it reduces the actual transmission distance by about 40%. So some planning needs to be taken into account. It's like anything else. Some planning, the installer has to plan it correctly, test it so that it covers the area that you really want to cover. The benefits of infrared, very simple installation. So I'm hanging a transmitter on the wall. I'm running the audio cable of whatever I want to transmit to it, and it's then on. That's it. It floods the area with light. Infrared, because it's line of sight, it's very good and it's very recommended for confidentiality and privacy. Because it's light, it can't penetrate through doors, windows, ceilings, um, uh, or floors. So I know that the sound is always contained within the room I'm in or the space I'm in. Once the doors are shut, the windows are shut, the sound, the transmission can't go anywhere. It stays within the room. Um, it's a good alternative to hearing loops where hearing loops cannot be installed, and hearing loops cannot be installed anywhere there's constraints and there are situations where you can't install a hearing loop. So this is a good alternative, also with low latency. Um, it's a more precisely controlled coverage for large areas. So because the transmitter is actually throwing out light, if I point it right or point it left or point it to the center, the light will move to where I pointed at. So I can control an area quite precisely with infrared transmitters. The ADA in the US provides a definition of the number of receivers that each venue should really have based on number of seats or number of users in each venue. So those are some of the benefits of infrared. And on the flip side, considerations. Number one, there is no installation standard. This is really important. Because there's no installation standard, it means that installer number one can install it to his or her understanding. Installer two would install it in a different way. There is less predictability for the user. Then the user might have different experiences with system one or system A. Obviously, the management and accumulated cost of the receivers, it can very quickly ramp up. For large venues, you might need 50 or 60 or 100 receivers. Those are personal receivers, so there's a lot of issue of maintenance here from the venue's perspective. If you think of a big conference or a big convention or an auditorium, the venue have to maintain the system, make sure that they're charged, they're clean, sanitized, the headsets and neck loops are available. So there's a lot more maintenance issue in comparison to hearing loops, for example. Finally, the most important point, probably because I'm transmitting the sound source through a ray of light, the technology is susceptible to sunlight. So number one, it is unsuitable to use outdoors because the light will just vanish, will just disappear. Number two is venues that have big levels of light. For example, if you got a whole wall of windows or a whole wall of large glass doors or panels that allow a lot of light into a room, or you have a room that's full of glass surfaces like glass tables or glass desks, that is the enemy of infrared, I should say, because basically the glass surfaces deflect and mess around the signal, the light. So really consider infrared if your room has a lot of windows and an excessive amount of light, and it cannot be used outdoors at all. Moving on to FM or RF, radio frequency. I'm about halfway, just over halfway, so pretty good. So radio frequency is similar to infrared in the sense that there is a transmitter transmitting to personal receivers. So in other words, I've got one transmitter transmitting the sound through the air, and every user that wants to access that sound has to have a personal compatible receiver. So in that aspect, it is similar, but from there on, it's a totally different technology, totally different transmission method. So assistive listening, RF system can do two things because it is portable and can be used outdoors or indoors, and it's a lot more versatile. It can be used as assistive listening, but also as a tour guide system. If it's configured as a system listening, you have the sound source, as you can see here at the bottom of the screen, the sound source coming into the transmitter, and the transmitter putting out a signal that can be picked up by receivers, unlimited number of receivers. So my sound source is my incoming sound, and my transmitter doesn't even have to be positioned in the same room. It can be positioned anywhere in the venue as long as I'm within coverage distance, of course. Um, so it's even easier, simpler than infrared because I don't need to hang anything on the wall inside the room. I can be in a completely different room. I'm not transmitting light here. I'm transmitting an FM radio signal through the air. If it's used as an assistive listening, sorry, as a tour guide configuration, then the transmitter will actually be the speaker. So the tour guide, the guide, if you like, wears or uses a portable transmitter with uh, different types of microphones that will speak into the microphone, and that will go directly to the receivers. So I don't need to wire in a sound source, and I don't need to install a transmitter in the audio room, etc. This is completely portable, a completely portable configuration that can be used outside. So the good things, the benefits of RF, there's quite a few. I mentioned it's versatile. It can be used as assistive listening or group guiding. It's a very simple installation. The signal isn't restricted by barriers, doors, windows, ceilings. It can penetrate through walls and through doors and through ceilings. So very useful in that respect. It can be used outdoors and in direct sunlight because again the RF signal is not affected by that. It works in a large spectrum of frequencies, so it can deliver a much wider range of frequencies in comparison to loops. For example, our new RF system delivers up to 12 kilohertz, which is plenty for music transmission, high quality music transmission. The receivers on the RF system, some of the receivers include very high amplified volumes. So for users that have hearing loss, but they don't use hearing aids and they require that extra boost of volume, those receivers, I think that one of our receivers goes up to 120 decibels, which is something like 60 or 70 times louder than standard volume. So that's a benefit as well if you are using it without a hearing aid. And again, multi-channel, it enables our system have up to 42 channels, so it enables you to use the same system in one venue in different sound sources and simply choose which channel you're using. So potentially on paper, you can have 42 transmissions in one venue transmitting 42 different sound sources, and the user can choose between which channel to hook onto and therefore the sound source. The considerations, again, there's quite a few here. So no installation standards, which is the same as infrared, which means there's no predictability of results always. It depends on the installer. RF is a radio frequency. It's transmitting on a certain frequency. So there is susceptibility for the performance, because if other RF equipment in my area is transmitting, is using the same frequency, that could have an impact on the performance. So it could shorten the range. The more cars we have on a highway, the lower the speed would be, and the more congested it will be, and it's the same here. If I'm installing an RF system in the countryside, in the middle of the fields, and there's no one around me, there's nothing around me for miles, um, it's the likelihood that I'm not going to have any interferences. On the flip side, if I'm installing in a big city center, there's a lot of stuff going on around me, a lot of stores and cars, and venues and stuff going on. The likelihood that my transmission range will be shorter. Um, the receivers of the the receivers of the RF system, just like the hearing aids, they require, just like the IR, require maintenance, replacement of batteries, charging of batteries. You have to give and collect the receiver from every user that comes into your venue. So there is maintenance aspect from the venue's perspective, and there is the aspect that as a user, I have to ask for a receiver. I have to put something on me that may be visual to others as well. Other considerations, there are some issues with licenses and frequencies. There are some frequencies that cannot be used in certain countries because of different reasons. Frequencies can vary, and also the conflict with other devices I mentioned. And ultimately, the issue of um, privacy and confidentiality, there is an issue here as well, because if I'm transmitting something in a room or in a space, there's nothing stopping someone else from having a compatible receivers, knowing what channel I'm transmitting on, the standing outside the wall or outside the room and hearing the transmission. So unless the system is encrypted, which is something that is very complicated and very expensive, um, most RF systems that are available now are non-encrypted, and therefore it's not ideal, for things like courtrooms and things like this, because it's very difficult to know if someone else may have picked up a receiver and is standing outside the wall or in another room and hearing what's being said in this room. So that has to be planned and controlled again. So moving on to Wi-Fi, audio over Wi-Fi as it's called. So audio over Wi-Fi is a different technology. It's transmitting the sound from a sound source through an existing Wi-Fi network. So it relies on an existing Wi-Fi network to transmit sound to receivers. Usually the Wi-Fi systems, or most of them, rely on a portable personal device, such as a tablet or a smartphone. So here you don't have personal devices like a dedicated receivers that you pick up from the venue. You either use your smartphone or use a smartphone that's given to you by the venue. The sound is delivered from the device, or from the Wi-Fi transmitter, to a Bluetooth equipment instrument. So it's transmitted once from the Wi-Fi transmitter to my smartphone, and then again from the smartphone to a Bluetooth equipped headset, telecoil with a neck loop, or a Bluetooth enabled earphones. And all of those transmission protocols, they all take power and take time. So you think of conversion from analog to digital every single time, and that increases the latency. So those conversions, even though they're happening in fractions of seconds, the results are not always ideal for the user. So users also, there's another issue here, which is the users have to be informed if they have to bring their own device. But essentially, this is how it works. It relies on a Wi-Fi network that transmits to another device that works on its own network, and that device generates its own secondary network, and then if I'm walking into this area with a compatible smartphone, I can then hook up to this network to receive the sound. Then I have to think of how I'm transmitting the sound from my smartphone to my ears. So the benefits of Wi-Fi is that smartphones are widely available. Every Wi-Fi network needs a bespoke its own app. So I can't just connect to any network. I need to have an app on my phone, on my smartphone. I need to know how to use this app. And the benefit is once I'm using the app should work for me every single time I come to the same venue. There is growing familiarity with how to use apps, so people now understand and use apps almost every day, even at older ages and different cultures and around the world. It enables freedom of movement. It enables also multi-channel selection. So if I'm walking to a venue and the venue has number of screens or number of broadcasts, and I want to tap into different ones in the next hour, I can do that very well through a Wi-Fi network. And it works well when the live sound switched off. So when the live sound from speakers or other audio sources switched off, it works really well for the user. So for example, imagine a sports bar or a fitness center where I'm going into my gym and there is maybe 10 different televisions transmitting different audio signals, but the sound is switched off. I can then hook in through the Wi-Fi network, through the app, and choose which one I want to listen to and flip between them. So it's very effective in that respect. Considerations, unfortunately, with Wi-Fi, there's a lot more considerations than a lot more cons than pros. Um, there is no installation standard. There is dependence on external variables. So the Wi-Fi system depends on a lot of external variables. As soon as you are reliant on external variables, you're starting to have potentials for problems and for a lack of predictability. So you're relying on LAN, the local area network. How good is it? How fast is it? How predictable the signal is. So in other words, if I've installed the system at 9 in the morning, is the system going to perform in the same way at 9 in the evening when 2,000 people have gone into a venue and are now using their smartphones and there's audio systems and Bluetooth systems, etc. It's all relying on that network. So in terms of speed, surrounding frequencies, there is another issues of apps. Every Wi-Fi manufacturer uses their own app. So if you go to venue number one, you might need the app of manufacturer number one. If you go to another venue, you need another app for manufacturer number two. There is no common ground in that respect. Privacy is very limited. If I know the logon details and the passwords, and I've got the right app, I can stand anywhere within the venue and receive the sound, and there's not really anything that can stop me from doing that. There is issue with latency, as I mentioned. Um, Latency is a real issue because it's difficult for any manufacturer of Wi-Fi system to predict exactly what the latency is because of the variables. So I could say 80 milliseconds or 90 milliseconds or 20 milliseconds, and it might be all correct in a certain point of time during the day. Other considerations, obviously, the usage of apps, the usage of smartphones, is it suitable for the demographics of the clientele that I have in the venue? Users must have headphones or earphones. One of the variables in Wi-Fi system is the performance of my smartphone. If you think about it, I go into a venue, I have top of the range, brand new smartphone with the top performance. And I also have a top performing headset or headphones. The person next to me have a 7, 8, 10-year-old smartphone with different performance. It's got a different Bluetooth protocol on it, and they use a very old headphone. All of those things impact the quality of the sound that's delivered to the users. So it's very difficult. It all comes down to lack of predictability with Wi-Fi. And again, the venues have to make sure that they have the infrastructure in place. They have to make sure that they have high-speed local area network connection. that the Wi-Fi network can ride on. If they don't have it, they're gonna have to go and install it first. So these are all considerations to think about. The Wi-Fi does not meet the ADA standards of assistive listening systems. It's also doesn't meet the standards of us as a company at Contacta. We do not offer Wi-Fi systems, and we do not manufacture one. Um, Wi-Fi on the whole has been um, more successful in North America. You almost don't see it outside of North America so far. The way it works at a glance, an audio source could be a microphone or whatever is transmitted into the local area network driver or router. That router is then transmitting to the Wi-Fi network assistive listening system router, and it is that router that creates the cloud in the area or creates the specific network that I'll hook into in the area. And then I need a laptop or a smartphone or a tablet to receive the sound. And then I need to think of how I'm transmitting it from my laptop or the tablet or the smartphone into my ears. So headset, headphones, Bluetooth earbuds, etc. So I'm moving on to the last technology, which is Bluetooth and Bluetooth LE. We will start with Bluetooth and move on to Bluetooth LE. I'm pretty sure that probably everyone in this on this call is familiar with classic Bluetooth, and I've been using it probably for many years. So the classic Bluetooth has started life as a short-range digital audio system. It's been integrated into pretty much everything: cars, smartphones, tablet computers, audio systems, etc. A listening device is paired into the sound source with a password and a username or a password usually for authorization. That means that it's very private and other users are not authorized, cannot tap into the sound. Classic Bluetooth is also working as a one-to-one only. So one Bluetooth transmitter will transmit to one Bluetooth device and lock up. Listeners can use their smartphones or can use any other headphones or earphones to access the sound, and it offers a high quality one-to-one communication in a short range. So classic Bluetooth will cut off after when it exceeds a range of approximately 10 meters. Latest Bluetooth technologies or protocols utilize new components. So protocols that we started seeing in the last few years, when Bluetooth LE came out, use different protocols and different components. They improve the transmission range, and also they're able to now offer transmission from one source to many. So it's called one-to-many, rather than the old Bluetooth. The Bluetooth we may have in our cars, classic Bluetooth is one-to-one only. This new Bluetooth able to offer better transmission range, in other words, more than 10 meters, and also one-to-many transmission. Bluetooth LE gives a wireless area network, which is technology that uses a lot less power. The old Bluetooth devices use a lot of power, so if you're using Bluetooth hearing aid, it drains the battery relatively quickly. Bluetooth LE doesn't do that. It's ideal, and it was developed not really for assistive listening, but it was developed for other sectors: home entertainment, personal entertainment, headsets, earphones, earbuds, etc. Um, Bluetooth LE can coexist alongside classic Bluetooth, so you can have a device with a classic Bluetooth, but also Bluetooth LE on it. Bluetooth Auracast broadcast audio is basically it's an alternative or a section of Bluetooth LE. So it offers additional broadcast facilities that can then be used quite effectively for assistive listening. So what Auracast brings along, it brings along uh, the ability to stream more than one channel or more than one source to receivers, but also it enables people to share their audio. So I can receive one audio source to my headphones or my device, and I can share it with other people next to me in the same room, etc. So talking about Auracast as an assistive listening system, and it's been in the news in the last couple of years. You know, everyone in this call has read about Auracast and has probably seen publications and articles, etc. The benefit of Auracast, it delivers high sound quality. So it's able to transmit in stereo, and it's able to transmit high sound quality in a much bigger frequency bandwidth than loops, for example, over greater distances and for one to many. So one transmission to unlimited number of users. It's less susceptible to EMI or metal or physical barriers up to a degree. So if I've got 10 windows and walls between me and the receiver, there will be an impact for it as opposed to if I've got no physical barriers. Users can share the audio. Smartphones are widely used. It's important to mention here that Auracast requires the use of smartphone and will always require the use of smartphones, and I'll touch back onto it. There is less venue management issues, so there's no concerns of hygiene and recharging receivers, etc. The installation is very simple. And in the future, it will have the ability to transmit sound directly to Auracast compatible hearing aids. So the Auracast system transmits the audio to anything that is Auracast compatible. It can be earpods, earbuds, a TV, a laptop, anything that has an Auracast compatible, including in the future, they started to come out now, is hearing aids that have a built-in Auracast receiver in them. They will be able to hook into the sound directly because essentially there'll be earpods. It is important to mention at this point that Auracast will forever need a smartphone. So if I go into a venue, if I will go in the future into a venue with my Auracast hearing aids, and there is an Auracast transmitter in the venue, I will need smartphone to do the handshake to discover the network. There is no button to press, and there is no automatic hookup or anything like that. It's the smartphone that discovers the Auracast network, and it's me having to choose the network to do the handshake to connect to my hearing device, whether it's iPods, earpods, or hearing aids. I've noticed myself in some publications I've seen in the media that it's not mentioned. I think that a lot of these publications that are in the media about Auracast talk about the benefits, but they don't necessarily give the whole story. So Auracast is quite similar to Wi-Fi in that sense. You need your smartphone, you rely on your smartphone to discover the network. It's probably not a bad thing because smartphones are very popular, but it's also a consideration. So the considerations, as you can see in this photo on the left, I need my smartphone to tell me there's an Auracast network and I will need to connect. Okay, very simple. You can see it on the left. It's going to be simple and it's going to be easy to use in that respect, but I need a smartphone and I need to know how to use my smartphone and all the rest of it. I don't know if my grandmother knows how to use a smartphone and will be able to use it. That's a subject to another discussion. Currently, there is no sound quality for the installation. There's no sound quality or installation standard. There is one being prepared. It's planned to be launched in 2027 or 28 for now. I want to go back to what I said at the beginning about standards. It took about 10 years to integrate hearing loops into a standard in the UK and into other standards. It will take time until Auracast is an approved technology that will be integrated into standards around the world. So the fact that it's available doesn't mean that it's approved by standards. Auracast direct to hearing aid connection, the capability is unknown. You have to remember there are many hearing aid manufacturers. The big seven manufacturers, as we call them, manufacture hundreds of types of hearing aids. Each one of them have different components, different chipsets. They are not performing in the same way. that would impact the performance of the hearing aid. So even though I receive the sound direct through Auracast, the sound quality and the performance in terms of latency and other aspects are going to differ from hearing aid model 1 to model 2. Very importantly, at this moment in time, I know that there's works going on. Not all hearing aid manufacturers signed up to include Auracast in their instruments. I know that some smartphone manufacturers have done it, but it's not, at this moment in time, it's not been accepted by the whole industry or by the whole hearing aid manufacturers industry. The user hearing instrument, that's another point to bear in mind. The life cycle is between 5 to 8 years. So the average of a user upgrading their hearing aids, which they will have to do in order to have an Auracast compatible hearing aid, is 5 to 7 years. So it's going to take a long time, many, many years for the entire population in the world or part of the population to upgrade their hearing aids and have Auracast embedded into their hearing aids. It's a new technology that's going to take many years to implement to the level of RF or IR or loops. And also the proof of concept of this technology working as assistive listening for hearing aid users is unproven and untested. It works and it works well, and James and I have tried it ourselves in a convention, couple of conventions, but it's untested yet as an assistive listening in hearing aids. Untested, unproven. Other considerations, the products will have to meet standards. It will also have to meet other national standards of different countries and organizations to be included. Smartphones are required for handshake between the Auracast network and the hearing instrument. Got to remember that, very important. It's not mentioned in most of the publications. It is very important to remember. There is reliance on external variables with different performance. I'm relying on smartphones performance, headsets performance, headphones performance, laptop performance, and other instruments that I might be using it on. They are all different. There's hundreds of parameters of performances. So it's very difficult. It's going to be very difficult to have predictable results here. Auracast is only a solution for large area applications only. I repeat, it's only a solution for large area. There is no solution for Auracast to a checkout at a grocery store. There is no solution for Auracast to a checkout in a bank or a ticket machine at an airport or a check-in desk at an airport. Auracast are talking about Bluetooth, are talking about a QR code that I'll be able to scan at a check-in desk to connect to speak to the person on the other side of the counter. But then there's issue with privacy, because the person next to me, if I'm standing in a bank, can scan the same code and listen to my conversation. It's not a coded system. It's an open system, one-to-many. So there's issues like this, there's practical issues that are not mentioned in publication, and it's really important to remember. Auracast offer no solution for integration and OEM. We install hundreds of systems in ATM machines, ticket machines, LED screens, check-in desks, where we install mostly hearing loops, sometimes RF transmitters. There is no solution for that from Auracast. So there's all these things that are listed here that have to be remembered, and it's a new technology that has a lot of marketing budget behind it, and this marketing budget is reaching the media, is reaching the news a little bit prematurely, in my opinion, personally. It's just things that have to be remembered. You reading stuff, I read stuff, but ultimately the articles and the pieces I'm reading don't always include all this information here. The way that Auracast works as a glance, very similar to an RF or Wi-Fi concept. So a transmitter installed in a room somewhere will transmit, will create a cloud, will create a network or a transmission cloud, if you like. And then everyone in this room will be able to tap into that sound once they've done the handshake through the smartphone. And it doesn't matter what you are using as long as it's Auracast compatible. It could be a cochlear implant receiver. It could be just earbuds, earphones, hearing aids, iPads, iPods. So anything that will have the Oracast built into it will be compatible. We'll be able to tap into the sound. So, 7 slides to go. So doing pretty well. Just to wrap it up and to talk about assistive listening in the 21st century, very important points that we wanted to highlight, and also what's available and what is our prediction as Contacta. So the keys, in our opinion, the keys to accessible future, to a hearing accessible future, actually. First and foremost is that any technology can be accessed easily by the user, and the users can hear with improved intelligibility. If we have a system that's installed and doesn't allow any improvement, there's no point of having it. Second point, from an installer's perspective or a venue perspective, mix of technology. The future will be a mix of different technologies, sorry. We have to really think of the user journey through a venue. Yeah. Do I really want as a user to drive into an airport, use a hearing loop at the car park ticket machine, use a hearing loop in the elevator, use an RF system in a meeting room that I've checked in, use infrared in another meeting room, or use a hearing loop at the check-in desk when I check my bag? I'm not sure it's convenient for the user. So mix of technologies is a really important aspect to bear in mind. Venues, providers, users are looking for a solution that works and available now. I'm talking to hundreds of people every week, and James does. And people need a solution that works now, in next month, in the next couple of months, maybe in 6 months when they're doing their installation in the venue. Education of audiologists. I'll touch on to this in a second. Technology is effective when it relies on hearing aids. There's total reliance on the hearing aids if I'm transmitting sound to hearing aids. So we have to have all hearing aid manufacturers on board. Otherwise, you walk into a venue and some users can use the system and some can't. Installation standards ensure predictable results. As from a specifier, an installer, a dealer, a distributor, use the most suitable technology for the environment. So look at the space. I think that Mr. Myers is on the call here. We are working on a project of an installation of a loop system in a very, very old cathedral. And guess what? If cathedral is that old, you can't touch the ceiling. The ceiling is too high, but you can't touch the floor. You can't cut into the floor or anything like that. So what do you use? What can you offer? We installed assistive listening systems. We still install them in venues that are 900 and 800 years old, where you can't touch the walls, you can't drill into the walls. So these things have to be taken into account. Use of new technologies, once they are tested, proven, and accessible for the user. There is no point of installing something today that will be accessible for the user in 10 years, because there is no benefit for 10 years. SNR, signal to noise ratio, is the king. Our ultimate goal is to improve the SNR by 15 to 25 decibels to bring the listening experience to the one of to somebody with a hearing loss to the one of someone with normal hearing. I wanted to include this. This is a letter. This is a declaration by IHAC. IHAC is the International Hearing Access Committee. So it's a body based out of Germany that includes underneath it representatives from all over the world, charities, the European Federation for the Hard of Hearing, the International Federation for the Hard of Hearing, IHIMA, which is a body that includes within it representatives of the hearing aid manufacturers. So this statement they issued a couple of years ago, and if we look at the third and fourth paragraph here, I don't know if it's too small. They're talking about the estimation of time for a transition from an analog system to digital audio streaming, i.e. Bluetooth or Wi-Fi. and it cannot currently be made. And there is reasonable reason to believe that telecoils and hearing loops usage will continue for the next 10 to 15 years and beyond. So very clearly they state that there's no prediction to stop the use of hearing loops or other technologies. The fact that there is new technology going to come along, it doesn't mean that one will swap the other. Win is on this call, and I wanted to thank Win for letting me use this slide. This is really good table that compares assistive listening very quickly. In terms of ease of use, the need to check out equipment, used the different applications it can be used, the standards, whether or not it needs a smartphone integration, latency, and whether it's available now. So it's just a nice comparison, very clear comparison of each technology and how relevant these things are for the technology. Talking about the future, 2 slides to go. So the future from Contacta's perspective, and also our involvement in the different standards and committees that we are involved with, including the Bluetooth committees where we are part of, is the assistive listening future is a coexistence of different technologies. There is not going to be one technology to replacing the other. Bluetooth or Wi-Fi manufacturers are not saying that their technology is going to be instead of loops. Loop manufacturers are not saying that their technology is going to replace Bluetooth or RF or infrared. We as Contacta manufacture 3 technologies, and I can tell you that we are developing currently products in 4 different technology. We've got new products in development in RF, infrared, hearing loops, and Bluetooth. So the future is going to be a mix of technologies, and we wouldn't invest in technology that we don't believe in. We wouldn't do that if we thought that there was one technology only to use. In terms of standards, the BS 8300, which I mentioned at the start, has started going through its new revision. So just so you can get your head around how long this takes, the revision of the BS 8300, which was launched in 2018, the work on it started in 2015. So now the work starts on a new revision, which in my opinion will probably be launched in 2027, 28. So this is how long standards take to be updated. About 10 years. The reason I keep mentioning the BS 8300 because even though it's a British standard, the BSI is an organization that provides or writes all the standards for all of Europe and then for the rest of the world. So the European standards, the IEC and the IE European standard are based on the BS standards, and then the standards we see in the US and in Australia and in other continents, India, for example, are all based on the BS 8300 as well. So there's just, it's the key source in terms of standard that everything else then runs from it. New standards, there's also a new standard that is being worked on for the last couple of years, and it's coming to an end very soon. It's a new standard that will define and qualify, sorry, that's a typo there. It's qualify an assistive listening technology. The standard is due to be released either at the end of this year or some point next year. And the standard will define what can be classed as assistive technology in terms of many aspects: installation, access to the user, latency, transmission predictability, etc. So this new standard is very important, and I think it's going to cause some it's going to have an impact in the world of assistive technology, assistive listening technology. And there's also a new installation standard for Bluetooth, which is being worked on, predicted to be launched in 2027 to 2029. That's a time frame. it's going to specify the Bluetooth, the new Bluetooth system installation standard. But like I said, the prediction is that the technologies will run in coexistence. It's really important from perspective of a venue and an installer, a dealer, to ascertain the right technology for each venue based on the characteristics and the best access to sound for the user. So, last thing to talk about is audiologist. Basically, audiologist is the key to assistive listening. Okay, without the audiologist, we can have wonderful assistive listening. If they don't have it in the hearing aids, they don't explain to people about it, nothing will happen. So, and that's been the challenge for us as Contacta for many years. It's nothing new, and we can see the same challenge all over the world. Audiologists are not salespeople, and very often they are not technical people. They don't always understand technology, and they don't necessarily always understand how the technology works. And they don't always understand the benefits that each technology can be can deliver to the user that just fit in with a hearing aid, whether it's been RF or IR, loops, Bluetooth, whatever. So they're struggling with explaining the benefit, understanding, explaining it to the users. Educating audiologists is something very costly, costs a lot of money. It takes a lot of time and resources, and I don't know anyone. I've been in this industry for over 20 years. I don't know anyone that has been successful in consecutively educating audiologists to a high level in a global or in a national level. Another thing to remember that most of the audiology chains that we see on the high streets and in downtown city centers, um, they are owned by the manufacturers. So Phonak have a chain of audiology, have many chains, GN Resound, Widex, Starkey, etc. They have their own chains of stores. I mean, in the US, there's one of the chains have 1,500 stores. So these are huge organizations. They own the store, not necessarily to drive assistive listening. They own the store for one reason only, and that's to sell hearing aids. So when you go into a store, they will try and sell you a hearing aid. They obviously do a hearing test and program your hearing aid, etc., correctly. So in terms of the stakeholders, their agendas are different to our agenda certainly, but there's that thing to keep in mind that the private audiology sector in many countries is driven by the manufacturers of hearing aids. It's owned by them. And finally, different countries. I know that there's been some questions about it before the webinar. The different countries have different structures for provision of hearing aids. Some countries have only private markets. So if I want a hearing aid, I have to go and buy it. Some countries have a nationwide or state-funded or nation-funded programs where I can get my hearing aids even free or partially funded by government. And that impacts the quality of the hearing aids, but it also impacts the functionality. State-funded hearing aids may not have Bluetooth. They may be stripped from the fancy versions like apps, etc. What we also see on the flip side is that state-funded hearing aids in most European countries do include obligatory inclusion of telecoils and will in the future as well. So some of our customers have asked James and I, what do I do and how do I know if hearing aids in my country or in my state have telecoil or Bluetooth or anything else? It's very difficult to know. Every country is different. There are private markets and state-funded markets, and it's difficult to predict and it's difficult to know. You have to work with the hearing aid manufacturers in your own country, with the audiologists in your own country to ascertain this, and maybe with charities and organizations for the hard of hearing that will have this information. But my point of this slide is audiologists are the key. We have to be in touch with them. We have to continue the discussions with them, the education, the conversation. Finally, I just want to say thank you and credit resources. I particularly highlighted hearingloop.org here in blue. And I wanted to mention hearingloop.org. It's a website that has gone through a transformation in the last few months by Juliet Sterkins and Wynne Wyman, who's on this call. Hopefully she's still here. Wynne, you have done an unbelievable job with this website. I have not seen a website that is more clearer in terms of advice and in terms of updated information about hearing loops. Sorry, not only hearing loops part of it, about assistive listening. Very clear definition of pros and cons, do and don'ts, standards. There's resources page full of information. I really strongly recommend anybody on this call to look at hearingloop.org. It's a wonderful bank of information and resources that gets updated constantly, and is really very useful, particularly for North America, but also for other countries. And yeah, just a list of resources where we took information from to complete this presentation. So took a little bit more than an hour, but I'll stop sharing, and James and I are here available to take questions. I don't know if there's been anything on the chat, James, because I can't quite see it. So I'll start my camera again. And James, if there's any questions you'd like to read, or if anyone wants to ask any questions, you can unmute your microphone on the bottom left, unmute it so your microphone is live, and then you can ask.
Hello, I'm Dharmendra speaking from India. Can I know the installation guide of this hearing loop? How do we install the hearing loop?
The answer to the question is a little bit longer for this webinar, but you have the email address of myself and of your Puneet and or James. We need to do it outside here. Is that okay?
Okay.
Thank you. Any other questions, guys? I'm just looking at the chat. Thank you, Karen. Good to see you. Hi, Peggy.
Hello. Again, I'm Dharmendra. Can you share the email address of yours? If I have any question, I'll send you a mail to Perry.
I will send you. We will send you an email. We have your registration on the log, so we will send you an email with the details.
Right, sir. Right.
Okay.
Okay. Thank you.
You're welcome. Okay. Any other questions, guys?
No, thank you very much.
Okay. So have a good day or good morning, evening, depending where you are, and strongly recommend to register to our next 8 webinars that will happen between now and October, and it's always on Fridays. And check your emails in case we've sent you anything that fell into the spam filters. Okay.
Thank you very much, Ran. It was a great presentation.
Thank you, Ad. Thanks. Bye-bye.